Bad news, guys. When I was going to upload today's lesson, I went to click the video file from the Zoom session. Unfortunately, it turns out that it looks like it's been deleted for some reason. So I'm going to have to quickly re-record this. I'm going to do that now. That does mean that I'm going to have to explain everything. And explain everything without student input, but the advantage is that I've done it already, so it should be more streamlined. And also because it's a short lesson, I'm not too worried about having to redo everything. So let's go through today's lesson. Lesson 27, developing a formula. We will be able to set up linear equations with two unknowns. Okay, now we're going to compare this to what we were doing back in 3D. In 3D, we were looking at one unknown. Okay, so a man, you could say a man spends half his money at the roulette table, and then wins $50 at the end of the night. He has, at the end of the night, he has $80 left. How much did he start the night off with? You could do something like that, okay, with just one variable. We're going to deal with two unknowns. How does that work? Today's fact is lesson 27 is the first odd or masculine cube. If you think about the first cube number is, if you go with 2 cubed equals 8, 3 cubed equals 27. I guess this is excluding 1 cubed, which is 1, but yeah. It was a bit weird because men back in the Pythagoreans used to have this weird idea that odd numbers were masculine, whereas even numbers were feminine. And I guess the theory was that an even number that can be divided easily, so therefore they must be weaker. But I kind of think it's a bit of a silly idea, a way to think about these things, because obviously, even numbers just look nicer and they work a lot better, and you can do a lot more maths with them. So I don't know, it's a bit of a weird idea. But let's get to today's lesson. Last lesson, what we did was we looked at literal equations. Now, a literal equation deals with two unknowns, just like as I said, but instead of solving these unknowns, what we were doing was we were instead of making these equations, what we were doing is we were solving them. So we were rearranging them to find, for example, in terms of x and y. So for example, as I said, this will become 2x plus y. 2x plus y equals 7. We could get y equals 7 minus 2x. Great. Or we could put it in terms of x if we wanted to. 2x equals 7 minus y. X equals 7 minus y divided by 2. So, yeah. Then what we did was we did the same thing with these situations. And even when you've got more than one variable, it's still pretty easy to do. We looked at this, which was another way of doing it with the equal sign. But this rearranging started to get us talking about these transposing. Transposing is all about swapping the main center of the equation. In this case, f is the center of the equation, is the subject of the equation. We want to manipulate this to make c the subject. So we need to get rid of the plus 32 by subtracting 32. We need to get rid of the multiply by 9 over 5 by dividing by 9 over 5 and getting c by itself. And then usually what they'll do is they'll then give you a question. Okay, well, now that we know we have an equation that will allow us to calculate c, what will c be if f is 212? And we use this all the time in physics and chemistry, sometimes in business as well. Because what we will want to do is we might have a nice equation that tells us, oh, this is a way to calculate the force if you know the mass and the acceleration. But you might have a question that says, no, I don't want to know the force, I want to know the acceleration. So you're going to go, all right, fine, I'll transpose it, and I'll make A the subject. And now I have an equation that I can use to find out what A is. And that's how transposing works. So getting back to this main idea that we were sort of talking about, we've got two unknowns. How do we make an equation like this? Well, how you make an equation like this is by developing it. We're going to start with an easy example first, and then we might do another bit more of a weirder example, but this is the common example that you will see all the time when you are doing 3F. This is the type of question that you'll get. Movie tickets cost $20 for an adult and $12 for a child. Construct a formula for the total amount paid by X adults and Y children. Now I normally get you to think about this. And I go, okay, how much will it cost if we have one adult? Okay, if we have one adult, well, one adult's $20, so $20, easy. Great. And I say, what happens if we have two adults? Well, there you go. With two adults, we've got 2 times 20. Well, that's going to be 40. Okay, well, what if you have three adults? Well, now this is getting boring. 3 times 20 is 60. And I say, okay, so that means if I have X adults, all you're doing is you're multiplying that by 20. So all I'm going to do is write 20x. And that's exactly what goes here. We write down 20x, and that is the price for the adults. If there's one adult, 20 times 1. Two adults, 20 times 2. The children, the same thing. $12 for every child. Now you might say, okay, the other clue for this is the word for. Remember, the word for is another way to say times. If you say for, if you see the word per, if you see the word each, those mean times. So in this case, $12 for a child, that's going to be times. If it was $12 per child, it would be exactly the same question. If I add the last part that I sort of skipped over really quickly, but I'm going to add these prices together because I want to know what the total amount is. I want to know what the cost to take these people to the movies, what C is. Now I've got a nice and easy formula. That formula is 20x plus 12y equals C. That is also a literal equation because there is more than one unknown. Okay, now we could solve an equation like this. Let's look at this example down the bottom. If a group of 6 adults and 14 children go to the cinema, how much will it cost? Well, we can solve this pretty easily. What we're going to do is we're going to say let x equal 6 because we've got 6 adults. X is for adults, so let x equal 6. We're going to let y equal, you guessed it, 14. So then I'm going to have c equals 20 times, not x, 6 plus 12 times, not y, 14. If I put this into my calculator, which I'm going to do right now, 20 times 6 plus 12 times 14, I get 288. $288. So that's how much it's going to take all these 3 families or maybe 6 families, I don't know, to go to the cinema. These are the classic questions that you're going to get with these exercises. They'll say some amount per, some amount off, but ultimately it's going to be a question where you've got to put some kind of multiplier for an unknown. I will say they do get a little bit more different. Let's go have a look at this example here. Stephen earns $23 more in pocket money per week than his brother for working in their parents' shop. If they combine their money, they have $99. How much does each boy earn? Now with this one, we could do the same sort of thing we did back in 3D. We could actually try and find a way to simplify this and to construct it, but I'm actually going to take a bit of a different path. Taking a different path because I want to show you guys a different way that you might think about this. Now, if I had a question like this, let's draw out some key ideas here. If they combine their money, okay, combining, that's going to mean, that's a clue for adding. They will have $99. It's going to equal $99 when I add them. We've got two people. We've got Stephen and his younger brother. Stephen earns $23 more. It's plus 23 on the younger brother than his younger brother. So let's start with this. Let's say that Stephen's money that he earns, we're going to call that S. And the younger brother, we're going to use a lowercase b. Now, normally what we would do is if we were trying to solve this using a complicated method, we would try and figure out, we would use that $23 more. But I'm just going to simplify it at the start. I'm going to say S, the amount of money that Stephen earns, plus the amount of money that the younger brother earns. If you combine the amount of money they have, that will equal 99. And that's sometimes a great place to start. It's a simple formula that we can build upon. It's something where we can start and go, okay, well, now that we know, what else can we do with this? Well, what else we can do is now we can start to say, Stephen earns $23 more. So Stephen's amount of money that he has is $23 more than his brother. So if I knew how much his brother made, if I added 23, I would have how much Stephen earns. This is something what we can do. We can take this idea and we can put it here. We're going to substitute S equals B plus 23. Now what happens when we do that? Well, we end up with everywhere where we see S, we replace with B plus 23. B plus 23 plus B equals 99. 2B plus 23 equals 99. If I subtract 23 from both sides, what that's going to give me, that's going to give me 2B equals, and if I go 99 minus 23, 76. Which means that the younger brother earns a total of $38. And I worked that last step out by just going, by just dividing both sides by 2. Now that I know how much money the younger brother makes, I know the older brother, Stephen, he's going to make 38 plus 23, which means that he's going to make a total of $61. Now, the main trick with a question like this, and the reason why I'm teaching you how to do it this way, is because I want you guys to see this. I figured out this equation quite easily. Okay? Yes, you're a good boy. I figured out that equation quite easily because all I needed to do was I needed to just substitute. I just needed to say younger brother, older brother together makes 99. That was pretty easy. This step here, that was pretty easy to do. If I knew the younger brother's age and I added 23, I got the older brother's age, and then I could substitute them together. That's the part that I like. I like that we don't have to try and do this big. I could have jumped straight down to this equation here, but that would have probably have gone, okay, I need to add the younger brother's age, then I need to add the younger brother's age again because that age plus 23 is the older brother. I like using two variables. Again, two variables, because then it's simple. It makes it, the idea is simple to understand. Older brother plus younger brother. Only later on do I substitute to get rid of one of those variables. Now we're going to take a little bit of a sidestep now to talk about something different. what I'm going to talk about now is nonlinear equations. Now, this is a very sort of different to the last stuff, but this is designed to sort of get you through 3G. Now, I'm showing you this now because I thought I might as well, and then on Friday, we don't actually have to do too much actual lesson. We can just spend some time talking about spend some time working on those 3 exercises. So, what is a nonlinear equation? A nonlinear equation is an equation, equations that have powers, specifically powers that aren't 1. So they might be squared, they might be cubed, whatever. They could even be to the power of -1, so 1 on x. But we're going to deal with those later on. What I want to talk to you guys now is how to solve these 2 quick little examples here. The first one, a squared. Well, the opposite of a square. How do I undo a square? How you undo a square is with the square root. So I'm going to square root the left and square root the right. That's going to cancel that a squared. So I'm actually going to end up with a equals the square root of 14. Now I'm actually going to write the square root of plus or minus 14. The reason we're going to do that is because if I had, for example, if I said maybe, let's just do x squared equals 4 and x equals the square root of 4, which is 2, that's correct. Because if I think about this, 2 times 2 equals 4. But it could also equal -2. -2 times -2 equals 4. So in order to memorize there could be both of those, I put a plus minus sign at the front. That's all you have to do to solve when you've got a square root problem here. With this example on the right, it's the same sort of thing except there's a couple more steps. 3f squared minus 12 divided by 5 equals 18. Okay, first thing I need to do is I need to find what is the furthest thing away from the f squared on this side of the equation. The furthest thing away from the f squared is this divided by 5. So I'm going to cancel that out by multiplying both sides by 5. 3f squared minus 12 and 18 times 5, that's going to be 90. Cancel it out so I didn't have to write it down. Let's get rid of this. The next thing we need to get rid of is the minus 12 because the 3 happens to the f first. So to get rid of a minus 12, I'm going to add 12 to both sides. That's going to give us 3f squared on the left. And 90 plus 12, okay, that's pretty easy. We can work that out. That's going to be 102. Next, to get f by itself, we're going to divide by 3. That's going to give us f squared equals 34. And once we've got f squared equals 34, we can just go f is going to be this positive and negative square root of 34. Now I'm not going to do any complicated square roots or surds or like, I'm going to approximate this. I'm just going to leave that answer because that's completely correct. And if I try and go through 34 is going to be 5.992, whatever, it's going to be an approximation. So I just like leaving my answers like that. Now that's actually all the work that we had to do. All you guys actually have enough now to do not only 3e, 3f, 3g, and 3h. What I want you guys to work on though first is 3e and 3h. I want those guys done by Friday. Friday's lesson we're going to work on 3f and then later on 3g. I might even set 3g as homework for the weekend. Okay, so that will be something you can get done. So then when we come back next week, we can start looking at 3i, which is going to be the next big topic. We're actually getting close to the end of this topic, so we might be getting close to another test. Before I move on, I want to show you guys some of the questions that you might encounter. So let's bring up 3f. Now, I can't show you, I can't use the pen here, so I'm gonna have to you're gonna have to sort of make do. But we'll have a look at these. So you can see with this first question here, the balloons are 50 cents each. The streamers cost 20 cents each. So we can pretty much see what's going to happen here. You're going to go 50 times the price for a balloon, 50 times the price, the amount of balloons, and 20 times the amount of streamers. And so these first few are very, very similar. All of these will usually have, you know, let X equal the number of coffees. Hey, a coffee is $3.50, so $3.50 times X. A lot of these are very similar ideas. Now, it does get a little bit confusing, I guess, when we get towards the later part, because that's when we start to, you know, the last sort of idea that we started to talk about with the amount of, with the price of the amount each brother would get. So for example, in this question here, so this one's sort of still playing around with that idea, but it makes it a little bit harder because then they want you to take the number of coins formula and convert that into a dollars formula. But look at this one here. Maria has 5 years older than George. The sum of their ages is 37. So hold on, before I do that, let's just do this. So I've got the questions now up in PowerPoint. These are the last two questions. This last one usually gives students a fair bit of difficulty, so I was going to explain it really quickly though. This one is very similar to this one that we just talked about with the brothers earning money. Let's have a look why. Maria is 5 years older than George. The sum of their ages is 37. That's usually where I'd start. So I'm going to say, well, we've got Maria, and we've got George. When you add their ages together, the sum of their ages is 37. Cool. All we need to do now is to go, well, Maria is 5 years older than George. So Maria, her age is George's age, but you need to add 5. And then I can take that and I can substitute that in. Again, this is why I like it. We're breaking, instead of trying to make one big confusing formula, we break it down into two simpler formulas. M plus G is 37. M, well, what is M? Maria's age is George's plus a little bit. This last one here is a bit of a challenge. A rectangular lawn is twice as long as it is wide. Okay, the lawn is 1 meter wide around it. It's got a 1 meter gap around it. The length of the perimeter of the outside of the park is 48 meters. What is the width of the lawn? Now, this guy here can get a little bit challenging. How I like to do these kinds of things is, well, let's just use two variables. Okay, we've got a length and we've got a width of the lawn. Okay, now we know for the width of the lawn that this is 1 meter here. And this is 1 meter. So if I wanted to know how long the whole side here is, it's going to be the width plus 1 plus 1. So the width plus 2. And down the bottom here, it's the same idea. I've got a 1 meter gap here and a 1 meter gap here. So the length across the bottom is going to be the L plus 1, which means L plus 2. If I wanted to find now the perimeter of this whole outside edge, that's going to give me, that'll tell me that perimeter around the outside ledge is going to be, well, starting from here, going across, we have L plus 2. Then we go down, plus W plus 2, plus L plus 2, plus W plus 2. Now I can simplify that. And I'm actually not going to simplify this for you because I want you to simplify this. But eventually you're going to end up with L's and W's. But that's not going to help because you're going to need to substitute something in. You're going to have to remember that the length is twice as long as the width. How do we use this for our advantage? Well, we're going to substitute later on the fact that we know that the length is twice 2W. You're going to substitute that in for L into whatever question you'll get. You also probably should substitute the fact that we know that P is 48. So that's going to give you some formula. 48 equals 4W plus something. I'm not going to tell you exactly what it is, but that is all you need to be able to solve that equation. So that's a little bit of help for you when you get up to that question, and hopefully a little bit of help when you get up to further questions. The lesson today I hope you've learned is that you can make complicated questions a little bit simpler by, instead of trying to put everything in terms of one variable at the start, do that a little bit later. Do that like afterwards. Maybe figure out, well, we know that the perimeter is going to be, we know that the length and the width, that's how we deal with perimeter. Well, let's deal with that later on. We know the ages. Let's deal with the sum of their ages. Let's deal with how their ages are different later on. Let's just start with the basics. And it's usually a good way to get 1 mark, maybe sometimes 2 marks. It's just to start with the basics. So yes, ladies and gents, what I want you guys to do now, if you aren't doing it, is make sure you get 3E and 3H done first, and then make a crack at some of these questions from 3F. I've been Mr. Greer. Thanks for listening.